Hello Game Makers, this is Game Maker Rob, and in today's episode we will be having our node generate paths for ourselves so we can see what kind of path actors will move along when we get to that in the next episode. So let's get started. Okay, so last episode we were able to fill an array with nodes that were within our movement range, and today we're going to make use of that data so we can generate a path and see an actor walk along it. So the first thing I actually want to do though is, because right now it's a little bit difficult to see exactly when we are displaying the nodes we can move to, it's not always clear what level we can move to, or when we change levels, all of the nodes for every level will get drawn, so it's not very clear. So we're just going to make another adjustment to our nodes. So in the create nodes region here, and the create a node for every cell, this one here, we're going to add a new variable called _level, and it's just going to record for every node the level that the node is on, and that's going to help us immensely for debugging and displaying that data. We may even use it in the actual gameplay as well. So that's all we need to do. And then the other thing in the create state area is we're going to make a new array called path, and it's just going to store the nodes that are going to be our path for an actor to walk along. That's all this is going to be for. And then down in our ready state, we have pathfinding. We're going to update that now. So previously when we were left clicking, we were just filling nodes within range with our script that we made last time. We have made a few changes, as you can see. This is the same, but now we've wrapped this line of code within this if statement, because what we're going to be doing is when we click the left mouse button, if we haven't filled nodes within range, then that's what we're going to do first. And then if we then click again, we're going to be generating a path from that array, and then we clear nodes within range so that next time we click again, this code's going to run. It just enables to test things pretty quickly. So on with the things we've added. So we're going to have a variable called path start node, which is going to record where we clicked originally to generate our nodes within range. So we're just going to store that there. And then if we have already filled nodes within range and we've left clicked again, that's when we're going to be using a new script. But the first thing we want to do is record where have we clicked on. So end node is going to be recording that there. And then path, our new array, is going to be getting its data from our new script, which we'll do in a minute. And we also want to make sure we're clearing nodes within range, otherwise this stuff isn't going to work too well. So once you've got that down, let's make a new script called str_generate path. It's a pretty small script. There's probably more lines of debug code than anything else in it. So we're going to pass it the start node and the end node and the path array. Sorry, I didn't put that one up there. So we're going to pass it the start node, end node, and path. I want to display in the output the start node and the end node, because if these two are ever the same, then we don't want to generate the path, or there's a problem, one of those two. So it just helps us to work out what's gone wrong if there's a problem. The same with all of these debug messages. If you don't have to include these, but if you run the game when I do and you don't get the same results, then I would strongly urge you to include these messages, and then it will help you work out what may have gone wrong. So anyway, the first thing we want to do with the actual code is set our current node to the end node. And if you remember last episode, every node has a parent, and we're going to be starting from the end node, and we're going to be getting the parent of the end node, setting that to current, and then getting the parent of that node, setting it to current, up until current equals start node, and that's when we know, okay, we've reached our goal, and then we can stop checking. So that was the point of getting parents in our script last time. That was the whole reason for it. Hopefully that explained it better than I did last episode. Okay, so you can see that we are adding the end node to the start of our array, which means when we're actually moving along the path, we're going to be starting at the end of our array, and then when we reach the very end node, we'll have gotten to the very start of the array, like that. So, like I said, as long as current is not start node, we want to keep getting the parent of the current node. I just have a little safety net here to say, okay, if the current's parent is not equal to no one, then that's fine. But if it is no one, that means we have a problem, because we're not going to be able to continue our path. So that's what this if statement is for. It's making sure, you know, there is a parent of the current node. So as long as there's a parent, add that parent to our path and set the current as the last node parent. And we're going to be showing the value of path, which shows you all of the entries of the array so far. And then if for any reason parent is no one, then we're just going to set our path. We're going to empty our path and break out of this while loop, and we're going to show ourselves a message. Again, this just stops us from having a never-ending loop. And once all this is done, we're going to return path, and path is either going to be empty or it's going to be full of nodes, hopefully. And that should be it for the step event. And then the last change I've made so far is in the draw event. So we have our test node within range for loop here. I've made a bit of a change to it, because rather than making another for loop and using that for path, I decided just to use the same for loop for both. So here we're just going to say if the array length of node within range is greater than 0, then A, standing for array, is going to be node within range. Otherwise, A is going to be path. And on line 45, it would have changed. It probably would have been line 41 thereabouts. But anyway, this used to be node within range. We've now changed it to A, so we can make use of these two lines. And then we're going to grab the node from our array. This is new, so this is going to help us check to make sure paths are working for stairs and that kind of stuff. So if the node's level equals the current level, then we're going to display it. Otherwise, we're not going to display it. That helps us with the visual aspect of it. So that should be all of the changes I've made so far. If we now run the game, we can see this in effect. So here I'm going to click on the grass and then click anywhere else, and you can see we have a path generated. It tends to favor diagonals more than anything else. There are ways to deal with that, so don't worry about that right now. If I click inside here and then click outside, you can see we have a path that takes us through the gate and out to where we clicked. If we click at the bottom of the stairs and then press up on the cursor key up and then click on one of these entries, you can see on this second story or first story, depending on where you're from, we only have 3 nodes. This is because on this level, these are the only nodes that we need to walk to. And if you press down, why do we have those there? I don't know. Okay, so we had a bug there. Basically, we had extra nodes in our path. This is because we weren't clearing it every time we were making a new path. So in the script we just made scr generate path, just before we add the end node to our path, we want to clear it like this. So we're just getting rid of the whole thing. I didn't have the bug before the recording because I was doing it had this script running in a slightly different way, and I changed it, which caused the bug. So that's why it happened. This is how to fix it. And if we run the game again, let's just check that moving up the stairs works fine. So here we are, clicking on the bottom of the stairs, pressing up, clicking here. You can see these are the tiles on the upper level that we're going to move to. And on the bottom level, we started here, and these are the path we made to get there. Ideally, we want to be moving in a straight line. There's no reason to kind of move diagonally. Like I said, it's something we can fix later on. It's basically, we're going to be giving different costs to tiles. Every tile is going to have a base cost for their value. So for example, these tiles here, this is going to have a greater movement cost than just regular grass. And we're going to be multiplying that value if a node is diagonal to another node, and that's going to mean that when we move in a straight line, it's going to be picking it would pick this node here on the straight line as opposed to this one. It will make movement look a lot better. Anyway, so that is our generating paths done. Okay, and the last thing we want to do today is just test this thoroughly, make sure it's working. So if I just generate lots of different paths working properly. And what about if we click on the outside? No crashes or bugs or paths. So this is exactly what we want. We want to be able to move to different levels and show a path. We're going to be able to click outside the allowed range and have no path. And we want to make sure that the path array gets cleared after every whenever we're making a new path, we want to clear the existing path. And that's it. Thank you for watching, guys. I will catch you next time. Bye for now.